everyone. Welcome to Cubstart iOS. I'm Abby. We're really happy to have you here. And our goal is to take you from wherever you are now, whether you have no prior iOS experience or just a little bit, and help you build a solid foundation in how iOS apps are made by the end of the course. So you should not only understand the tools, but also feel much more confident turning your ideas into real apps. So here's the overall plan for our day, and we'll start with some motivation for why iOS development is worth learning and why this space is exciting. After that, we'll go through the course logistics so you will know how the class will run this semester. Then we'll briefly go through Git, which is a useful tool when we in our real development workflow. And after that, we'll move into Swift, which is the programming language we'll be using. And announcement, a few quick announcements before we start. So make sure you're in the correct ad and Grayscope. Ad is going to be the main place for course communication, updates, and questions. So if you have a question about an assignment or course logistics, post it here. If it's private, make a private ad post instead of emailing us. Uh, and Grayscope is where you will submit your assignments, so make sure you join as soon as possible if you haven't already. Also, because this semester is fully online, the course materials are meant to be accessible anytime. That means the slides, recordings, and assignments should be things that you can come up to on your own schedule. There's no attendance requirements this semester, so the expectation is that you keep yourself on pace and use the posted materials constantly. Okay. And please let us know if you have any feedback. Maybe make a private ad post. And here are our instructions instructors.
Yeah, so I'm Justin. I'm a EECS fourth year, and I've been in Cubstart for one, two, three, four. This is my sixth semester teaching, so it's been quite here a lot.
I'm Abby. I'm a third year major in EECS, and this is my first semester teaching this class. And I actually took Curbside iOS in spring 2025, and I generally like it a lot. That's why I came back. Yeah, I hope you guys also you will enjoy it. So introductions. We're done with introduction. Then let's move to logistics. So we're on week one. We'll learn some basic Gits and also like fundamentals of Swift. And we will have our homework one release after this lecture, and it will due next Friday. And here are the grading. So homeworks was 25%, mid-semester 30%, and final project checkpoint is 10%. And we will ask you to maybe have a prototype on Figma and submit it to Grayscope. And for our final project, we'll have a demo day and it will worth like 25%. And you can access everything as we stated before on the course website. And homework, yeah, I just talked about. So our weekly homework assignments will release after the lecture and due next Friday. If you join the course late, it's completely fine. Just make up the homeworks and turn it in. And we will have a mid-semester project called Class Planner. Around week 4 to 5, we will introduce this project, and this is where you start moving from a smaller practice task into something that feels more like a complete app. So the purpose of this project is to combine the concept from earlier weeks and use them in one place instead of only writing isolated piece of code. You will have to think about structures, screen states, and how the user interacts with the app. And it will also build a good fundament foundation for your final project. Okay, so later in this semester, you will work on the final project. You will design and build an app in a group up to 4 people, and the topic is something you can choose. This is one of the best part of our course because you can get to stop following a predetermined template and instead building something that reflects your own interests and ideas. And more details requirements will be released after later this semester, but in general, you will prepare both slides and a live demo, and we'll have about a month to work on the project from start to finish. I think that's enough time to build something meaningful if your scope is you scope it well, but not enough time to waste like 2 weeks and like panic at the end. And demo day will happen during RR week, and there are usually prizes for your category like best UIs, community impact, etc. So the final project is both a technical milestone and also a chance to show off what you made. And here are some pictures from our previous demo day. So the prize for best UI and all the prizes is a teddy bear, which I wanted when I was in Cubstart. Okay, so let's move to why iOS. Both Justin and I are a big Apple fan. That's why we're here. And apps are basic like everywhere, and we use them for productivity, communication, entertainment, and planning. In a lot of ways, apps has have been become extensions of how we interact with the world. If we want to organize our day, there's an app. If we want to communicate, there's an app. So that's a huge part of why this field is cool and the things you make can feel immediately real and immediately useful. So idea to reality. So one of the best thing about app development is the pipeline from problem to publish. You know there's a problem, that problem turns into an idea, the idea becomes an app concept, then you code it. If it works, you can publish it and put it in front of real users. That process is kind of amazing when you think about it. Something that started as small frustration or random thoughts into your mind can end up as a real product on a phone screen. And if you publish it, other people can use it too. This is one of the reasons I like this course so much when I took it. Building from nothing, then seeing the thing actually work in real life. It's just a very satisfying loop. So why so special? I think iOS development is special because it sits right at the intersection of design and computer science. On one side, you cared about UI, UX, accessibility, graphics, interactivity, and how the product feels for the user. On the other side, you care about logic, data models, algorithm, architectural decisions, and how everything works under the hood. So when you build an iOS app, you're not only writing code, you're also like shaping an experience. You're making technical decisions, but you're also making products and design decisions. The combination is what makes the field so satisfying. So compare with some other areas of CS where the output feels more hidden and abstract. app development is very visible, so you can see what you built, touch it, and improve it in a concrete way. Yay! So what you can do, the short answer is a lot. You can build productivity app like a to-do list app called Things To, or like tracking apps that you can track your flights, and also games that we loved. And how to build iOS apps. When people build mobile apps, there are generally two broad approaches. One is native development, where you use Apple's own tools and frameworks to build for Apple platform. The other is cross-platform development, like React Native or Flutter, where one code base tries to target both iOS and Android. So if you've heard people say things like, "Oh, why not build it once and run it everywhere?" Where that's the cross-platform side of our conversation. It's a real option, but people do use it. But in this course, we focus on native iOS development because that gives you the clearest view of how Apple apps are actually built. Okay, so wait, why native? There are a few big reasons. First, if Apple releases a new framework, new design system, or new API. Native development lets you adopt it right away, and you are directly using Apple's own stack, so you don't have to wait for some other layer to catch up. And second, native development is generally better aligned with platform changes. If Apple updates UI behavior or system conventions, native tools can are usually the first to support those changes as well. And third, performance is usually better because the tools are optimized for the hardware and software they're designed for. So finally, if you want to tap into device hardware like uh, the camera, photo, or system capabilities, native APIs usually make that more direct and natural. So if your goal is to actually understand iOS development deeply and build things that the Apple way, native is the right place to start. Okay, I also want to briefly explain Apple's release cycle because this is part of the iOS ecosystem and help you understand why the platform keeps changing. So typically, Apple releases public OS version in the fall. Then around June, there are WWDC, which stands for Worldwide Developers Conference. That's a big event where Apple introduced new developer tools, frameworks, APIs, and design directions. So developers get access to beta versions first, then the public beta arrives later, and eventually the full public release comes out with the newer iPhone. In the iOS community, people often call WWDC dub dub. So if you hear that phrase, that's what it means. The larger point is that being an iOS development means learning in an ecosystem and that updates everywhere. So part of the job is not just learning once and stopping. It always it's always also paying attention to how the platform evolves and what new capabilities become available. Yay. So this slide is an example of what Apple can introduce at WWDC, which is liquid glass and also new APIs like Alarm Kit, Background Task API, Foundation Model API, and more. So when you make your app, you have access to them. And this is partly a technology point and partly a mindset point. iOS development is not static, so the platform keeps moving. That's part of what makes it fun. And how to build iOS app? So the tool we're using is Xcode. Xcode is Apple's integrated development environment, or IDE. It is the main application where you will write code, run your app, debug issues, or preview your UI. If you're building for Apple platforms in a serious way, Xcode is the home base. So you will need a MacBook, but if you don't have one, just post a private app post. And Xcode is where you will code and honestly where you will probably live a lot while building apps. It includes an editor, debugging tools, simulators, Swift UI previews, and the rest of the main tool chain you will need to develop and test your app. One important detail is that some APIs are tied to OS versions and Xcode versions. So we expect you to have Xcode 15.0 plus or N and macOS Ventura or newer. And how do we build iOS app? The language we're using is Swift. Swift is the programming language that lets you write logic, computations, algorithm, and data models. So if your app has users, tasks, cards, classes, settings, or game states, Swift is how you represent and manipulate those things. For example, if you build a planner app, Swift will let you define what course is and what a task is, what dates and times look like, and what should happen when a user edits or saves something. It gives a structure to your app's behavior and data. And it has some helpful, unique features that others don't have. And the third piece is Swift UI, which is a UI framework we use to build interface. Swift UI is a framework that controls what the user actually sees. So instead of telling the UI every tiny step manually, you describe what the interface should look like and how it should behave given the current state. So Apple provides basic building blocks like tags, images, and buttons, and you will compose those pieces into more complex screens using layouts such as a vertical or horizontal stack or other containers. So we'll talk about it later in this course. And it's also cross-platform. So that means the same general framework can target macOS, iPadOS, watchOS, tvOS, and visualOS. The key idea is that Swift controls the logic and Swift UI controls the visual layer. So beyond Swift and Swift UI, Apple gives a developer a huge number of frameworks that extend that apps what apps can do. You can think of you can think of frameworks as pre-built tool sets that help you add major capabilities without reinventing everything yourself. For example, if you want to embed app maps like the 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 flight app, there's map kits if you want onboarding or discoverability hints, there's tip kit. If you want local persistence data, we use Swift data. And if you want widgets, there is widget get kit. If you want speech recognition, there is speech. And that's really just scratching the surface. This is also where it makes sense to mention that later in the semester we'll talk about Firebase as well. Firebase is not an Apple native framework in the same sense, but it's a very common tool for storing and syncing data in apps. So when I say this course covers design, front end, and data storage, I mean that we're not stopping at make a pretty screen. We're also want you to understand how apps can manage real information in a more realistic way. All right, now we're gonna cover the higher level motivation and the core iOS stack, which is Git. Git can feel a little abstract the first time you see it, but the basic workflow is manageable. It becomes essential the moment you start doing real project works, especially if you're collaborating with other people. So it is an open source version control system. In plain English, that means it helps you keep track of changes to your code over time and lets you go back to previous versions if you need it. So if you break something badly, gives you a structured way to recover instead of just panicking and hoping undo somehow saves you. And GitHub is a cloud-based hosting service for your code. It lets you store your repository online, share them, collaborate with other people, and access them from different places. A repository is basically just a project. So uh, it's a garage for your project. So if someone says push your repo to GitHub, that means push your project here. So this slide shows the relationship between a local repository and the remote repository. So you push your code from your local repository and to the cloud, then your teammates or your partner can git clone your work from the cloud. So you can actually working on the same code base. And this is the core Git workflow. So first you have your workspace, which is just where you add the file normally. Once you made changes, you use git add to move selected changes to the staging area. And the staging area is basically the place where you decide what is about to become part of the next saved snapshot. And then you use git commit along with a commit message to create that snapshot. You can think of a commit as taking a picture of the project at a certain moment. After that, git push sends that snapshot to the remote repository on GitHub. So if someone else has already pushed changes, then you use git pull to bring those changes down. So the loop is edit, stage, commit, push, and pull when needed. Once you use it a few times, it will be less mysterious. It will be so useful. And you can use Git in the terminal, and that's useful to learn, but Xcode also has a built-in source control support. So you do not have to do everything through raw command line commands on day one. You can do it through Xcode. So at this point, we covered the core structure, why iOS development is exciting, the main pieces of the iOS tool stack, and how Git fits into the workflow. Now we're ready to move into Swift fundamentals. We were getting more concrete with the language itself.
Cool, thank you, Abby. I could switch the screen share. Um,
Yeah, sure.
so thank you, Abby. We're now talk about Swift fundamentals. So in programming, we can basically what programming is most of the times you're manipulating different types of data. So here in Swift, we have these six primitive data types, so the most fundamental data types. Um, so sorry, let me move the my screen into the side. So
Oh, you
okay,
didn't
so we
share.
have these six primitive data types. One of them is called int, which is
Justin,
basically
you
integers.
you didn't start sharing.
Oh, my bad. Is it not? Wait, can you still see my screen or no?
Mm, oh
Okay.
yeah. Oh yeah.
Me. Okay, is it okay? Can you still see it?
Yeah, yeah, yeah.
Okay,
It's
perfect.
perfect.
Um, so integers, we have floats. Floats are basically decimals. Doubles are also decimals. The difference between floats and doubles are that doubles have greater precision, so that means that they're more accurate, more precise. So most of the times, just use doubles rather than floats. Booleans are a type where they can hold a true or false value. So they can only have those two states, true or false. And there's character, which is basically a single Unicode character. And a string is basically a sequence of those characters. So again, like I mentioned, programming, you're manipulating data, but how do we actually store data? So in most programming languages, if not all of them, there's this concept called variables, and variables are a construct to hold some data. So to declare a variable, this is how we do it in Swift. So we use the var keyword and the variable name, colon, and then we declare the type of the variable, in this case, which is int. So this variable is of type integer. And then we can assign it a value using the equal sign. So this equal sign, a single equal sign, does not mean equality. What we're doing here is assignment. So we're assigning the value of 19 to this variable called age, of which is of type integer. So we're assigning the integer value 19 to a variable called age. Now, how do we manipulate it? So we could do some operations like arithmetic operations. So here on the second line, what we're doing here is, again, we're not checking if age equals age plus one. What we're doing here is we're assigning a new value, right? The single equal sign means assignment. So what we're doing here is that we're assigning the value of the expression age plus one. So we're going to evaluate the right-hand side first. So 19 plus one is what? It's 20. So then we assign the result of that expression, 20, to the variable age. So now age is updated to hold value of 20. So we could also print the value out. So when there's this method, or we have this operation called print, and then you basically pass whatever you want in it, and it will basically output it to the console. So if you do print age, we'll get 20. Now, here's a similar piece of code, but now we're changing the var to a let. So that single change does quite a bit. When we try to do the same subsequent code, this so currently, right, this is still var. Everything works. Oops. Sorry. Um, okay. What the let keyword does is that it makes it immutable, so it's not changeable. So what we had before with age equals age plus one, that's not going to work because age, once it has a value, in other words, once age is initialized to something, or initialized meaning it's being assigned to something already, if we try to mutate this variable with a let, the compiler, which is basically the program that converts our code to binary, that program will alert us saying, "Hey, this is not valid." So, okay, so we have this piece of code. Now Swift is sort of intelligent. So what I mean by this is that it can infer the types for you. So right here we have :int, but we can actually drop that and just do var age equals 19. And the reason why we could drop that is since we're assigning the value of 19, Swift is smart enough to infer that we're assigning an integer to a variable. So we can drop types in Swift when declaring variables. There's another data type called tuples. Python also has this. So a tuple is a comma-separated list of types enclosed in parentheses. And you can name the elements inside those tuples and refer to them later on. So, for example, let's say we want to represent a coordinate pair, so an x and value pair. And usually, right, they're both connected. So we want to kind of use a data type that encapsulates both of these two values. So here we have this variable called chord, and it's initialized as tuple, which is you create a tuple with these parentheses and has these two elements, x and y. So I can access these values, x and y, using something called dot notation. So I could use chord.x, chord.y, and I could also synonymously use 0 and 1, so numbers. So I could use chord.0, chord.1. Using this period, this is called dot notation, where you're accessing a member of some data type. In this case, these members or properties are x and y. And again, functionally they're the same thing, but this just syntactically they're different. Now, when we're storing data, we can have a lot of data, right? And so in Swift, there is sort of a grouping of types called collection. More on a technical level, there's this collection is actually a protocol. If you have used Java before, that's the interface. But what it does is that it kind of declares a grouping. It basically declares some similar behavior for a set of things, for a set of types. So arrays, sets, and dictionaries are under this collection protocol or collection kind of group. So arrays are a unordered list of elements, a list of things. Sets, sorry, arrays are ordered. My bad. Arrays are ordered. Sets are unordered. So there's no ordering to sets. And another thing about sets is that you cannot contain any duplicates. So everything in a set is unique. A dictionary type is sort of like like a real dictionary, right? A real dictionary has words that map to their respective definitions. And so a dictionary in Swift has a set of keys and values. So we have a single key, a unique key that maps to a value. So let's take a look at how do we create an array in Swift. So again, array is ordered. So all of the things in an array have a specific order. So here we have this birds array that's currently initialized to an array of strings. We call the things in an array elements. So sparrow, the string eagle, the string hawk are elements. And one condition of a array is that everything or all the elements within the array have to be the same type. And arrays can have duplicate elements. So we have two sparrows. And again, they have an inherent ordering. What I mean by this is that let's say we want to access sparrow, the first sparrow, we can use something called indexing. So you can see we're printing birds and using these brackets. We're in the brackets, we're saying bird 0. What does the 0 mean? Well, each one of these elements are assigned a number, and we call that number index. So sparrow lives in the 0th index, eagle the first index, and the hawk the second index. So to get access to the first sparrow, we index into birds via 0 index, and then hawk, we use this index 2. Now, if you used Python before, Python has something called negative indices, where if you do -1, it starts on the very end, so hawk, but Swift does not support that, just FYI. So we can also have some additional array operations, like to mutate this array. There's this, I guess, action called append, where we're appending a single element. So if we do birds append owl, it will add owl to the very end of the array. There's one called a different version of append contents of, where you're appending not a single element, but you're appending an array. So here we're appending the array hawk owl. So now we have sparrow, eagle, hawk, hawk, owl. And again, arrays can have duplicate elements, so that's why we're using two hawks. We can also remove things. So we can remove an element via its index. So removing the element at index 1. Well, what lives in index 1? Sparrow is index 0. Index 1 is eagle. So now when we remove it, we're getting just sparrow and hawk back. Okay, so that was a quick kind of tour of variables and arrays. Now let's kind of talk about how we can control data flow. So here we have these two variables, let and name, and we have this kind of code. This is called an if statement. So what the if statement is that the very first line has a condition. So this condition is saying age less than or equal to 1. So we start at the very top. So we check to see if this condition is true. If it's true, we go into these curly brackets of this first condition. And if it's true, right, we print name is an infant. Now, what's cool about this is Swift has this kind of feature called string interpolation, where we're able to embed a variable within a string. So how do we string interpolate? We use this kind of slash and then parentheses of your variable. And this is synonymous to, again, a lot of languages where you basically concatenate multiple strings together using the plus operator. This is a very kind of elegant way to do this in Swift. So obviously age is not less than or equal to 1, so we go to the next condition. Is age less than or equal to 4? That's not true. So it keeps going until we go to is age is less than or equal to 17. That's still false. So this very end, you see this else case or clause. That gets triggered when all the previous conditions are false. So it's a kind of a catch-all kind of clause. So in this case, we actually print out Joshua is an adult because none of the previous conditions are true. Now, we can also, there's this concept in programming called loops, where you need to iterate over a collection. So here we could see that we have a for loop that, uh, so this for loop has three things, right? First, we have this I, that is the variable. After the in keyword, that's our collection. Now, in this case, there's a concept in Swift called ranges, where we're able to specify like a range of things. So there's two types of ranges. One of them is called half open ranges, where the first number is inclusive, the second number is exclusive. There's closed ranges where the first number and the second number are both inclusive. So if you think of math, you can think of those like intervals where in half open range, right? The first one is the parentheses, and the second one is the square bracket, right? Whereas the closed ranges, both of them are brackets. So in this case, in this for loop, right, we're starting at 0 and we're assigning that to the variable called I, and we're printing it out. And then we go to the next one. The next one is 1, and then we're assigning it back to I, and then we're using it and we're printing out it again until we reach 4, right? And we're not printing 5 because this is a calf open range. The second one, we exclude that number. We can also iterate or loop through arrays. So this is how you would do it with arrays. We could also do it with strings. Now, it's important to note that each letter is not of type string. It's actually of type character because a string is made up of characters. There's also a similar thing with a for loop called a while loop. So a while loop and for loop, you could rewrite a for loop into a while loop, and you could rewrite a while loop into a for loop. But basically here we have the main thing is that a while loop has a single condition and it repeats whatever it has in those curly brackets until this condition is false. So what this code does is this is the Fibonacci sequence. So it's going to print out 0, 1, 2, 3, and so forth. All right. So here we have something called functions. Now, we use functions a lot when we're coding. And the main motivation is that sometimes we have sections of code where we repeat a lot of, right? And when doing so, we don't want to rewrite that same piece of code multiple times. So we use something called functions to help encapsulate that piece of code, and we can reuse them. So how do we declare a function? We use the func keyword then followed by the function name. And then a function can take in values. So we call these things the actual values that we give it arguments, but the variables that are assigned to these arguments, we call these variables parameters. So you can see we have two parameters right here, and we need to specify the type of these parameters. And then within this function, we have some code that can act upon these parameters, and we can also return things outside of this function once it's finished executing. So to kind of call or run this function, this is how we do it. You just basically use the function name and then the parameters, and then you basically pass in the arguments, the values to those parameters. So let's take a look at an example. So we have this function called greet that takes in two arguments, person and hometown, and it returns something out. So how do I know what it returns? Well, on the subsequent part of this function, you can see we have this arrow that returns of type string. So this function expects to return a string out. And so here within this function, you can see we have this string that is using string interpolation. So we have person, we have hometown. Now, what's really kind of uh, weird is that if you look at the second parameter, we have two, right? We have from and we have hometown. So what are these, right? Because most programming languages, you probably have only seen one. Well, the first one is optional, and it's called the argument label, and that's used when you're calling the function. So this from is being used at the call site. So if you look at the bottom, you can see that we're saying greet person Tim from Cupertino. And then the second one is actual parameter name, and that's used within the function itself. So the person, right, the first parameter, that's person is the argument label and the parameter name. So if you look at this print statement, right, and you kind of read it, it's very smooth, right? It says, greet person Tim from Cupertino. If we just have hometown, right? Great person Tim, hometown Cupertino. That makes sense, but it's kind of less fluent, right? Less easy to read. So in Swift, if you think a function can be rewritten or written in a way that's readable, take advantage of using argument labels so that, again, when you're at the call site, it just makes a lot more sense. So we can actually also omit having argument labels at all, or the parameter names, by putting this underscore before the parameter. So once we do that, we could just basically omit having to say the parameter name. So you just add two numbers, 2 to 3, add two numbers, 8. Now, for the add two numbers 8, The reason why we only have one argument is because here you can see at the function, we have these equal zero for both of these parameters. Those are what we call default parameters. So here, if we have attitude numbers 8, automatically assigns the parameter a to 8. And then since we omit the second argument, Swift is going to fill in b with 0. So it's going to assign 0 to b because b has a default parameter value. So when we're calling attitude nums 8, what we're doing is we're returning the expression value of 8 plus 0. And also really helpful data type is called enumerations, or shortly, they're called enums. So enums declare a common type for a group of related values, and they're usually for things that can be represented by a list of discrete cases. So for example, let's say I want to model the four states of matter, right? Solid, liquid, gas, and plasma. Now I can have four different variables and to keep track of these things, but I can group them together into something called a enum, called matter state, and I can access these different cases. And again, it's important to note that if you are deciding whether to use a enum to represent things, they have to be discrete, right? They need to be exhaustive. You can't have an infinite number of cases and kind of encapsulate that in an enum because, again, to define an enum, there is a finite set of things, a finite set of cases. And here on the right, we're using the same kind of enum, but now applying to directions, right? There's only four directions, right? Left, right, up, down. So I could really kind of easily encapsulate that using an enum called direction. Now, a switch statement, I think it might be a better if. So it considers a value and compares it against several possible matching patterns. If one of these patterns or cases are matched, it jumps to that case and executes the appropriate block of code. And this provides an alternative to the if statement if you're handling multiple potential cases, because a switch statement, right, it automatically jumps to that case. Whereas an if statement, it goes by one by one by one by one. An important thing is that a switch statement must be exhaustive. What that means is that you have to consider every single possible case. What works really well when dealing with enums is using a switch statement. So here we have this example, we have this variable called current direction, which is of type this direction enum that we saw in the prior two slides. And we're assigning this to the case left. Now, again, since I already declared the type direction and the type, I could just use dot left. But if you drop the type direction when in the variable declaration, you could just assign it to direction.left. They're the same thing. So here's the switch statement. So we're switching upon current direction. Now within the switch statement, we have to consider every single possible case. So as you can see, we have two kind of cases that I've listed out, left and right. So right, current direction is left, right? So switch automatically goes to the code associated to the left case. So we're going to print turning left. But as you can see, we're missing up and down, those two cases. But those two cases are covered by this default case. This default case is sort of like the else clause that we saw in the if statement. And so anything else that is not left and right, it goes to this default case and it prints or does whatever is inside that case. It's cool. So we're running a bit about time, but I just want to quickly kind of show you this kind of, I'm just gonna copy and paste what I have here to this kind of problem. And so here, this problem we're we have this 2D array. What do I mean by this 2D array? It's basically an array that contains arrays. So this function, right, takes in this 2D array called tiles, and it takes in these another array called recognized tiles, and it takes in this argument called empty count. And so what we're trying to do is that we're trying to see if this 2D array tiles is a mosaic. Now, a mosaic is considered, or this tiles is considered a mosaic if all of the tiles are within recognized tiles and there are a specific number of tiles left untiled. So how do we know if a tile is untiled? It's using these empty string. So we need to see if the number of empty strings are the same as empty count. So, okay, so let us, again, we're running out of time, so I'm just gonna kind of paste it in within here. So here we have these three helper variables. We have this one that takes in, basically computes the number of rows using tiles.count. Here we have create a set. So again, there's recognized tiles. Again, if we have any duplicates, we don't want any duplicates. So we create a set. Here we have another variable that keeps track of how many empty tiles we have. And then here in this for loop, we have two for loops. Now this is called a nested for loop. So on the first outer for loop, we're looping over the number of rows. So we're going row by row. And then for each row, we're going through that row. Now, a row can have a different column count. So what we need to do is that we need to loop through that rows. So this is a particular row, right? At index I. We need to get its count. Now, here we are accessing a single tile. So here is the row, right? And then here, right, this I is representing the index for the row. The J is representing the index for the rows column. So we can use the syntax to index into the ith row. So now we're getting the tile at the ith row at the jth column. So then we check to see if it's the empty string. And if so, we increment empty tiles by 1. But if it's not empty, we need to check to see if that tile is within this recognized tile set. And if it is contains, right, we can continue onwards. But if this is true, if the tile is within the set, we don't want that. So if this is false, right? Sorry, if it's not contains, right, then this is false. This exclamation mark basically inverts that Boolean's value. So if this is false, right, this tile is missing in the set. This is true, and so it returns false. And when we're returning within a function, we basically immediately exit out. So none of this code gets ran. But all goes well. Once we finish executing this for loop, we then check to see if we have this condition, right? If the number of empty tiles count is equal to empty nums. So yeah, that is the solution for this kind of problem. And it kind of combines a lot of different concepts that we use today, like variables, sets, for loops. And what's interesting to note is that most operations on sets are constant. What that means that the time for it to complete this operation, this contains, does not depend on the number of elements within the set. If we have this as an array, when we call contains, array also has contains because contains is a method or function. Any type that is a part of this collection protocol has this contains function. But an array, if you call contains an array, it needs to go through every single element, which is not effective, or efficient. And so, again, one of the things about sets is that most operations on sets are constant. So this gets it instantly, right? It doesn't, the time that it takes to find contains does not grow with the number of things within the set. You could also you also need to check the empty tiles, but this piece of code kind of illustrates a more, using set operations where we're basically getting the tiles and then we're seeing if that is if it's a subset of the recognized tiles. Again, that's a bit more advanced, but that's something that you could check out. All right, so I'm gonna go back to these slides. So you can take a look at the code here on with this gist and get play around. So to conclude, there's a lot of resources available out there, especially a lot from Apple. So we have some articles that we have. You can also there's really great YouTube links and resources. There's also this app called SF Symbols by Apple, and these are symbols that you can use within your apps for free. And there's a lot of great properties like you can animate the symbols, you can do so much more. But yeah, so today's lecture, we talked about why iOS development is cool. We hope that you're excited to develop iOS apps. We taught you a lot of iOS lingo. So now you talk to people about iOS, you sort of have the kind of capabilities to talk in more technical manners. We also learned how you can use Git to fit with your workflow. We learned about how to build iOS apps using Xcode, Swift, and Swift UI. And we talked a lot about Swift, how to represent data using variables, different types of data types like arrays, how you can control data using if statements and loops, and much more.